Hello everyone, my name is Sidra Bukhari and I am a PhD research scholar in Department of Biochemistry, Quaid-i-Azam University, Islamabad. Our research interest includes the identification of different natural and synthetic compounds that shows anti-cancerous and therapeutic potential against leukemia. The title of my presentation is Role of doxorubicin coupled Nanoceria in modulating TRAIL and NF-kappa B pathway in leukemic rat model. Nanomedicines are developing as one of the new treatment options against multiple diseases. This study was designed to explore the anticancerous potential of nanoceria that are commonly known as cerium nanoparticles, and this combination we have coupled the nanoparticles that are cerium oxide nanoparticles. We have coupled them with a chemotherapeutic drug that is doxorubicin, and we call this combination as a nanomedicine. We have tested the efficacy of this drug against acute myeloid leukemia in Sprague Dawley rats. Uh, signaling pathway that we studied in this study was TRAIL and NF-kappa B pathway. TRAIL pathway is a apoptotic pathway that induces cell death in cell, while NF-kappa B pathway is a anti-apoptotic pathway that prefers cell survival. So this was the overall introduction of our study. Moving towards the methodology, first of all, we synthesized the cerium nanoxide nanoparticles. Then we coupled these cerium oxide nanoparticles with doxorubicin, that is our chemotherapeutic drug. And after that, we have done the characterization of these nanoparticles by different methods. Then we induces leukemia in Sprague Dawley rats, and we divided these Sprague Dawley rats into 5 different groups that are shown below. And these groups are normal, leukemic, nanoparticle, doxorubicin, and at the last, that is our nanomedicine nanoparticles that are loaded with doxorubicin. After the dissection of all these groups, we move toward the hematological studies. We have done hepatic and renal marker profiling. We studied the analysis of apoptosis through Annexin V assay. And for the gene expression studies, we extracted the mRNA from the tissue, then we synthesized cDNA against those mRNA, and then we had done real-time PCR. So these are some of the results in the figure one, panel one. You can see that it shows the XRD analysis of our different groups. Then in the panel B, we can see that it is the UV absorption spectrum that shows the significant peak was obtained at 320 by our nanomedicine. In the figure in the panel C, you can see the results of FTIR of all the three therapies that we have done, and in the panel D, that is the emission spectrum of our therapies. In the panel E, that is shown here, and you can see that these are the SEM micrographs of our 3 different experimental groups. So this was the characterization of the nanomedicine that we have performed. In the figure 2, you can see that this is the DLS in which we measured the size distribution, average size, and zeta potential of our therapeutic drug. And after these characterization, we move toward the results that we obtained from the our rats groups. And in the figure C, you can see that this is the relative organ weights of liver, heart, and kidney. That you can see in panel A, B, C, and A, B, and C. In the panel A, this is the figure of a liver, and and you can see that the in nanomedicine that is shown at the end, the nanomedicine was the one, and in the heart, the nanomedicine was the therapy that reduces back the level of organ weight of liver and heart. So the nanomedicine in this case manages to lower the weight of liver and heart that was increased in the case of leukemia. This is the figure of blood parameters. You can see that in panel A, the results of WBC, lymphocyte, eosinophils, neutrophils, monocytes, and hemoglobin are shown. And these blood parameters were measured in every group in our five groups, five experimental groups. And you can see that the nanomedicine and our these three therapies manages to revert the condition back to the normal. Like in the case of WBC, the level of WBC in leukemia was increased, while the nanomedicines and nanoparticle doxorubicin and our nanomedicines manages to revert back the condition of WBCs back to the normal. So by calculating these overall blood parameters, we came to the conclusion that the nanomedicine was the drug that significantly reverted back the condition back to the normal. In the figure 5, these are the hepatic and renal biomarker results, and we can see that the nanomedicine against reverted back the condition of rats back to the normal in ALP, AST, ALT, and also the level of creatinine. So, in case of leukemia, the level of ALP was reduced while the nanomedicine reverted back to the normal. So in same is the case with the AST and ALT, the level was increased in case of leukemia, and our nanomedicine significantly reduces the level of AST and ALT in different rat groups. And the level of creatinine, it was also increased, but the nanomedicine and the nanoparticles both manages to reduce the creatinine level in rat groups. So in figure C, you can see the percentage of apoptosis that we measured through an Annexin V assay. And you can see that in the normal group, the apoptotic cells, or the percentage of apoptotic cells was 4%, while in leukemia it was 77%. And this apoptosis was increased in case of our nano group, that is nanoparticle, cerium oxide nanoparticle, and doxorubicin. So this nanomedicine increases the percentage of apoptosis in AML cells. Moving toward the gene expression studies of our two signaling pathway, TRAIL and NF-kappa B pathway. This is in the figure 7. You can see the results of gene expressions of TRAIL pathway. This is the DR5, which is the marker of trail pathway, and a CFLIP, that is the inhibitor of trail pathway. We can see that the level of DR5 is significantly reduced in leukemia, but our nanomedicine completely enhances the expression of DR5. Same is the case with the C-flip, that is the inhibitor of trail pathway. The inhibitor of trail pathway in the case of leukemia was highly increased, while our nano drug manages to decrease the expression of C-flip, that is the inhibitor of trail. And the caspase 8, that is really important for the induction of apoptosis. We can see that only our nanomedicine, that is the nanoparticles coupled with doxorubicin, manages to increase the expression of caspase 8. So all of this study shows that the nanoparticles not only induce apoptosis, but it triggers trail pathway for the induction of apoptosis by increasing the expression of DR5 and decreasing the expression of C-flip. Same is the case with the NF-kappa B pathway in the figure 8. You can see that we have used two markers, REL A and REL B, for the study of NF-kappa B pathway. And for both the markers were increased in case of leukemia. And when this marker was increased in case of leukemia, that prefers the cell survival, but the nanomedicine manages to revert back the condition or down regulates the expression of REL A and REL B, which shows that the our nanomedicine inhibits the NF-kappa B pathway by down regulating the REL A and REL B pathway. So at the end, our results shows that the cerium oxide nanoparticle may enhances the apoptotic potential of doxorubicin both at cellular and genetic level. And we have also studied that it also inhibit the pro-survival NF-kappa B pathway markers as nanomedicine, and it also rendered itself as a potential therapeutic agent against acute myeloid leukemia. So this was our all study against cerium nanoxide nanoparticles for the to prove that they can be a good therapeutic marker for the study of leukemia, specifically acute myeloid leukemia. Thank you so much for your attention.